Welcome back. Today we're going deep inside the human body to show you exactly what space does to you, system by system, bone by bone, muscle by muscle. And trust me, by the end of this video, you will never look at gravity the same way again. Let's start from the very moment the capsule splashes down in the ocean. The astronaut has been in zero gravity for 180 days. That's 6 full months of floating. The moment the hatch opens, gravity is no longer optional. Medical teams are waiting right there because the astronaut physically cannot walk out alone. Here's the first major problem: muscle atrophy. In space, your muscles have absolutely nothing to do. On Earth, every single step you take, every time you stand up, your muscles are fighting gravity. That constant fight keeps them strong. But in space, there's no gravity to fight. So your body says, why keep these muscles? And it starts breaking them down. Studies show astronauts can lose up to 20% of their muscle mass in just one mission. That's why when they land, they literally have to be carried. Their legs just don't work like they used to. Now, let's go even deeper, into the bones. This one is actually terrifying. In space, astronauts lose about 1 to 2% of their bone density every single month. That's the same rate as elderly people with osteoporosis, but happening 10 times faster. And when they return to Earth, those weak bones now have to handle full body weight again. The fracture risk is extremely high. Now let's talk about your heart. In space, your heart actually gets lazy and shrinks. On Earth, your heart works hard to pump blood upward against gravity all the way to your brain. In space, blood floats. It distributes evenly. The heart doesn't need to work as hard, so it doesn't. When astronauts return to Earth, their heart suddenly has to work overtime again. This causes dizziness, fainting, and dangerous drops in blood pressure. Here's something wild. Astronauts in space literally get puffy faces and chicken legs. It sounds funny, but it's a real medical issue. This happens because in zero gravity, the 5 liters of fluid in your body shifts upward toward your head. Astronauts describe it as feeling like you have a constant head cold, stuffy nose, pressure behind the eyes for months. And that fluid buildup leads to one of the most serious long-term problems: vision damage. The pressure inside the skull pushes on the optic nerve and actually flattens the eyeball, permanently changing vision. NASA found that nearly 70% of male astronauts come back with permanently. Space also messes with your immune system. Your body's defense army starts malfunctioning. Viruses that were dormant in your body, like chickenpox, can reactivate in space. Your body can't suppress them anymore. And then there's radiation. In space, cosmic rays penetrate your body constantly, damaging DNA in real time. So how do astronauts recover? It's not quick, it's not easy, and it takes months of intense rehabilitation. For the first 2 weeks after landing, most astronauts can barely walk. They need help even getting out of a chair. By week 4, they start rebuilding strength, but bone density takes much longer, up to 3 years to fully recover. NASA has entire teams, doctors, physical therapists, nutritionists, all dedicated just to bringing an astronaut's body back to normal. But here's what most people don't talk about: the mental challenge of coming back. After seeing Earth from space, a tiny, fragile marble in the infinite darkness, coming back to everyday life feels surreal, disorienting, even depressing. Space exploration is one of the most incredible things humans have ever done, but the human body pays a real price for it. Every astronaut who goes to space is not just a scientist or a pilot. They're a human test subject, volunteering their own body for the future of humanity.